All right, in this video, we're going to look at how to use Desmos to graph several function or to evaluate several function values using a table. So here we're going to start with f of x is x squared minus 3x plus 1. We're going to evaluate f of 3, f of 0, and f of negative 1. So we'll go into Desmos, and rather than define f of x in a line and then have a line where we evaluate f of 3, f of 0, and then another at f of negative 1, instead we can use the table feature of Desmos. So to get the table feature, hit this little plus sign here and select table. So notice we have x1 and y1, and this is also the way you can create scatter plots in Desmos as well. Well, I'm going to go up to this y1 and delete it completely. And over here, I'm going to put in the function x squared minus 3x plus 1. But because this first column says x1, rather than type in x squared into Desmos, I want to type in x sub 1 squared. And to do that, it doesn't really require any special knowledge. So to get x1, we just type in x and then press a 1 right after, and Desmos will know to put it in as a subscript, and we want to square that. And then, because my memory is getting bad because I'm old, minus 3 times x and then plus 1. So then we're going to have minus 3 times x, which again we need to use x1, and then plus 1. All right, and we'll hit enter, and it says empty lists are not allowed, and this will go away as soon as we fill in values for x1. So we're going to start with evaluating f of 3. So for x1, if we put in a 3, f of 3 is going to give us 1. 3 squared is 9, minus 3 times 3 is also 9, so 9 minus 9 is 0, and then 0 plus that 1 is 1. Our next one will be f of 0, so we can just plug in a 0, and we also get 1, and at negative 1, we get a 5. So f of negative 1 is 5. And this table feature is also very helpful if we're looking at limits. So if we want to maybe see what our outputs are getting closer to as x gets closer to 3, we could put in something like 2.99. And then the next line below that, we can put in like 2.999. And then the line below that, we can put in something even closer to 3. 2.999999, and notice the outputs here are getting closer and closer to 1. So here's how we can also use Desmos to numerically evaluate limits. All right, that about does it for this video. Hope you found it worthwhile and educational, and